Good morning, good afternoon, or even good evening then, Year 7 mathematicians. We are starting now a new topic, and we're going to be starting with some fractions work. So if you can draw a line under previous work, put today's date, and the title is Adding and Subtracting Fractions. Now, just as a bit of a recap, your do now task is we have got this selection of 9 different examples on the screen there for you. I would like you to tell me which of those representations show 2/5. Explain your reasoning behind them, and what are you assuming when answering this question, and why might someone think that all of them would represent 2/5? So there's a clue in there, they don't all show 2/5, but why might some people think that they do? So if you just pause the video there and work your way through those and think up explanations as to why you've selected the ones you have. Okay, so coming back to this then, I would say that first one there is true, but perhaps you may have seen this another way. To show 2/5, there are 5 squares there in total. I've chosen the fact that the 2 white ones could represent 2/5 of the total. You may have gone for the coloured in ones as being 3/5. But that one I would say I could argue that would be 2/5. That's probably the most common one that people may make mistakes on. Yes, there are 2 that are coloured green and there are 5 that are white, but that would mean there are in fact 7 in total, so 2/7. I would say that one has shown. I'll pop up the rest of the answers for you now. Okay, on that one, this just appeared false there as well. Again, there are 5 different sections and only 2 have been shaded. So 2/5 of the sections have been shaded, but if you look at it, they're not all equal size. So you can't show that that is in fact 2/5 of the entire shape has been shaded, because the sizes of each section are not equal. If you look on the other examples that are on this page, all the diagrams have got equal parts, it would appear to be. And again, on that last one there, I've gone with the pinker parts there being representing 2/5. If you've gone with the white parts, you might have thought that would show 3/5. It can show both on that. So, as I said, we're going to be looking at adding and subtracting fractions. So, we're going to look at converting between mixed numbers and fractions, and we'll get some definitions of exactly what these are. Adding and subtracting fractions that have the same denominator, and the lesson after we'll look at when they've got different denominators. And then we'll add and subtract fractions from integers. And hopefully you remember an integer means a whole number. Okay, so this is your hook, and I'm not going to give you the answers for this because we're going to come back to it towards the end of the lesson. So there is an equilateral triangle and a square, and they're put together to make the shape of a house as shown. What is the total perimeter of the house? So if you sketch those drawings into your book, if you feel confident, have a go now. But if not, we're going to come back to that later in the lesson, and with the knowledge you pick up throughout, we should all be able to then answer that at the end. Okay, so here's the first question we're going to look at to get a little bit of an understanding on fractions. What extent do you agree with this statement? And I want you to give an example and an explanation if you do or perhaps even do not agree with this statement. A fraction is always less than 1. Now, I would say most commonly you do see a fraction that is less than 1. For the example that appears first here, 2/5, we say is the representation 2/5, numerator on top, denominator underneath there. That is what most fractions we see will look like. But in fact, a fraction will not always be less than 1. It could even be 1 itself. It could be 5/5. Or we could have where the numerator is larger than the denominator, so 6/4. And we'll explain later how to get these into mixed numbers, is in fact 1.5, so that's larger than 1. And the fraction on the right hand side, where the numerator is larger, is known as an improper fraction. Okay, so first things first then, what I'd like you to get copied down into your book is an example here, clearly labelled numerator and denominator. An improper fraction is when the numerator is larger than the denominator, and it will sometimes be referred to as a top-heavy fraction. So if you can get that example down, and then the orange box as well for me, please. Okay, so this is when we're going to start combining now mixed numbers and improper fractions to see if we can convert between the two and are confident knowing how to do so. So on this diagram that we've got here with these bar models, Sophie says the diagram shows 2 1/4, whereas Ron says that it shows 9/4. Who is correct? And again, justify your answer. So if you pause it there, give yourself a minute or so to think that through, and then we'll have a look. Okay then, year 7. So on this one, I would in fact agree with both of them. That both Sophie and Ron, what they have said is correct. In terms of Sophie, there are 2 full bar models coloured in. That represents the 2. And 1/4, there is 1 out of that final 4. Okay. Ron has said 9/4. If you count up the total number ones that have been shaded in that sort of yellowy green, bear with me, I'm hideously colourblind, but we'll go with yellowy green there. There are 9 in fact that are shaded in, and they're in blocks of 4, so we would have the denominator as 4, numerator as 9 to represent the shaded in. We're going to show how we can convert between those two to explain that a little bit further. Okay, so a fraction that looks like that, 1 2/3, sorry there, it's a little bit blurry. This is known as a mixed number, or again, sometimes you may hear it referred to as a mixed fraction. It is made up of an integer and a proper fraction after it. So there's 3 main types of fractions that we are going to be looking at, and you need to be aware of and know the difference between. Okay, there is a proper fraction, where it's just the numerator smaller than the denominator. Then we've got the improper fraction, where the numerator is larger than the denominator, and a mixed fraction, where we've got a whole number, an integer, involved there before the fraction. Okay, so on this one here, how do the following representations show the same thing? So again, I'd just like you to have a look over these. We're not necessarily going to give out some answers for these, but we're going to see, the more we go through this PowerPoint, exactly why these show the same thing. Okay, so hopefully you started to recognise a few of those and perhaps can see why they may all show the same thing there as a fraction of 7/5 or as the mixed number 1 2/5. So, what I want to look at now is what's the same or what's different about these number lines below. So I'd like you to copy these number lines down exactly as they appear, so use the squares in your book there to put those lines on, and we're going to show 8/5 on the number line and then write it as a mixed number. Okay, so on this first one, to show 8/5, you can see from 0 to 1 there are 5 sections. Each part of that will represent 1/5. We've split it into 5. So to go 8/5, we're going to go 8 along, and that's where our arrow would be. And then if we wanted to show that as a mixed number, we can see the nearest whole number we've got there is 1. It's 1, and then 3 lines after that, 3/5. 1 3/5. So on the second one, 2 2/3, we know we've got the integer of 2, so we're going to go past the number 2. We've got it split into thirds, and we need 2/3 of those, so it'll be the second line across there. That's where our arrow will go. And then if we want to convert that as an improper fraction, you could count how many lines we've gone across. So in total, there are 8 lines that we've gone across, and that's 8/3. Okay, so if we just make sure we've got those written down, I say we are going to keep building upon this to make it even clearer as we go through. Okay, so I'd like you to now, using that information, copy out these number lines and write each mixed number as an improper fraction. Now you can do it exactly as it appears there on the screen, just 3 number lines, and you can fill 4 answers on each one. Just remember as well, to see if you can convert those mixed numbers to improper fractions, to see if you've picked up an idea of how that would work, and then we'll see if there's a quicker method for it. So if you just pause the video there and have a go at those for me, please. Okay, so answers will appear now. I'm just going to have some arrows showing. So if you just mark these again for me, please. So that's the first one, 3.5, 5.5, 6, 9.5. I'll put the improper fractions up after I've done all the arrows. So question 2, 4.5, 7.5, just gone a little bit to the side, it should be directly above that line there, obviously. Then a half, and finally 10, part 3, 1.5, 8.5, 2, and 6.5. Going through as improper fractions, they are appearing now for you. When it's a whole number, we wouldn't actually need to write it any different. We can just leave that as a whole number. Okay. And again, there for 2c, a half, that is already exactly as it is as a fraction. We're not going to need to rewrite that as an improper fraction. We can't make the numerator larger than the denominator and keep it as an equivalent fraction. Okay, so this is now the method that some of you may have seen already, but let's just make it clear for everyone. To convert a mixed number to an improper fraction, we will follow these steps, and I'd like you to draw this nice and big with a box around it in your book so you can refer back to it. You're going to multiply the integer by the denominator, add the numerator to this, and then write it above the denominator. So we need an example to go with this to make it a little bit clearer. Convert 3 and 1/5 to an improper fraction. So first step, multiply the integer by the denominator. Integer is 3, the denominator on that fraction is 5. So we do 3 times 5 is 15. Add the numerator, which is 1, 15 plus 1 is 16, and then write it above our original denominator, 16/5. So make sure you've got that example next to the orange box in your books for me, please. And then we're going to go the other way. Improper fraction to a mixed fraction. So to convert back the other way, you'll divide the numerator by the denominator, write down the whole number answer, then write down any remainder above the denominator. And again, this should become a lot clearer with the example. So convert 11/4 to a mixed fraction. Firstly, you will divide the numerator 11 by the denominator 4, and write down the whole number answer. So that will give you 2 with a remainder of 3. Okay, write down the 2 and then write down that remainder, which is 3, above the original denominator, and you'll get 2 3/4. Okay, so we're going to get some more practice with this. So I'd like you to write each amount as a mixed number and as an improper fraction. Doesn't matter which one you pick first, whether you do the improper fraction first and convert to mixed number, or vice versa. So if you pause the video there and have a go at those representations for me, please. Okay, answers are appearing now for you. We should get 1 2/5 or 7/2, 7.5 or 15/2, 7 2/6, which you may have written as 7 1/3 if you'd simplified that, fantastic, or 44/6. Last one, 6 2/6, which again, 6 1/3 if you'd chosen to write that, and that'll convert an improper fraction to 38/6. Okay, if you had chosen to do 6 1/3, you would then perhaps have 19/3 as your improper fraction. Okay. So we're going to copy these into our books as well, and again, because you've got square paper, this is very, very easy for you to put down. Complete the following calculations. What is 1/3 plus 1/3? So I've got my bar model there, I've got 3 boxes because they represent a third each. If I have 2 of them, I've now got 2/3. Okay. Now if I had 1/6, and then I took a 1/6 away, I would end up, in fact, with 0. The answer doesn't always have to appear like a fraction. It can still have an answer of 0, like any integer whole number answer as well. Now the last one, 1/12 plus 1/12 would be 2/12. If we then to take away 1/12, we'd only be left with 1/12 with that. For some reason that's come up as 3. I've made the classic error there of not noticing the negative, so please pay attention to that as well. That's one of my deliberate mistakes, clearly. That should be 1/12. That last one is 1/12. I've made the catastrophic error of adding the 3 together. That's 1/12, that last one. Okay, well, we'll blitz past that mistake there. So, nice and simple tip for when adding fractions with the same denominator. So remember, the denominator is the number underneath. You add the numerators and leave the denominator exactly as it is. So for example, 3/7 plus 2/7, you'd add the numerators, 3 plus 2, leave it over 7, so that's 5/7. So again, that yellow box this time, we changed the colour. If you copy that into your book, says the nice big go-to tip for adding and subtracting fractions, and put that example down. So obviously when subtracting fractions with the same denominator, you wouldn't add the numerators, you would take them away in the order. So if it's 3/7 minus 2/7, you'd do 3 minus 2, which is 1 over the original denominator, 7. So it'd be a 7th in that case. Okay, so now's the time for purposeful practice. 10 questions. As per usual, you're going to need to write the question out, and as long as you can follow that rule we just looked at, then you can race through these. I reckon you could do this in 3 minutes, and then if you do the think ones on the right hand side there as well. Where you can, by all means, simplify the fractions if you're comfortable with that, but don't worry too much for now. Okay, so if you pause the video and have a go. So, answer brain now. You get 2/3, 10/11, 7/10, 6/8, which you may have gone to 3/4, as it being simplified, 8/9, 6/7, 10/12, which would go to 5/6, 11/12, 3/4, and 8/9. The think ones, 2/5, 0, 1/5, and the last one would be 0. I paid attention to the addition and subtraction symbols there, so hopefully you did as well and got those answers. Okay, this time, same again, but this time we're going to do subtracting fractions, so be very careful with those signs. Copy out those 10, and the think ones are a little bit more difficult. Now, I'll give some example answers in a minute, but there is more than one answer for those. So if you pause the video once again, copy those out and do the working in your book there for me, please. Okay, going through these then, we should have 3/10, 5/9, a 1/6, a 1/3, 7/12, 1/11, 5/7, 2/12, which you may have called 1/6 again there, 1/10, 3/9, and that would then simplify to a 1/3. Okay, so the think ones, I say there could be a variety of answers for some of these. I've just gone with what I've put in here. Will come out in a bit of a weird order there. 3 1/4 could go to 13/4. 1 2/3 is the same as 5/3. And then the last one is a beautiful example there using algebra. So if you remember, to convert a mixed number to an improper fraction, you would take the whole number, which is the number in front of the fraction, in which case this is represented by the b. You multiply it by the denominator, and then you add the numerator. So if we first multiply by the denominator, b times a is ba, or we'd probably just write that a little bit neater in alphabetical order as ab. Okay, b times a and a times b mean the same thing because they're commutative. Okay, doesn't matter the order for it. So if you were to use numbers, you know that 3 times 4 is the same as 4 times 3. Works the same for algebra. So we've multiplied the whole number b by the denominator a, and then from our rule we had to then add the numerator, so that would be ab plus c, and then you leave it over the same denominator, which is a. ab plus c all over a. Well done if you've done that last one correctly there. That really shows you know exactly what you're doing with adding and subtracting fractions. Okay, so I am a fan of these where there are missing numbers. You're going to have to work your way through and fill these in as well. So, once again, pause these, draw out the number line, and you need to fill in the denominators and then put an arrow on the number line as to where that shows. Okay, so having a look at this then, we should end up with, okay, it's done a bit of a weird, apologies for that. A quarter plus a quarter makes 2/4, which is shown as a half. 2/4 on our number line there. 0/5 just ends up as 0, so we can point that there. We need 3 lots of a third to make 3/3. That makes 1 in total. 3 divided by 3 is just 1. And then the last one, our favourite fraction we seem to have got for the day, is 2/5. So, a couple of thinking questions here then. How many fifths will be added together to make one whole? And you're going to put a diagram to justify your answer there. How many sixths or sevenths do you need to make a whole? And then can you generalise there then? Okay, so look at this. How many fifths will we need to add to make one whole? You will need 5 fifths. Okay, so if you had your friends round and you want to split a pizza between 5 people, you'd have a fifth each, but all those obviously back together would make the whole pizza. Likewise with 6 and 7ths, to have a sixth to make up to one whole, you will need 6 sixths and then 7 sevenths. Okay, so to generalise, whatever you're going to be taking there, if you want to take 1/9, you would need to have 9 of those to multiply together to make a whole. So if our numerator is just 1, whatever number we've got as our denominator, we're going to need to multiply it by that many times to make one whole every single time. That is reliant upon the fact our numerator is just 1. Okay, this one again, how many different ways can you make a whole using sevenths? Okay, so the first couple, there's obviously only one answer. Then the third one, you've got a bit of freedom and see if you can use some slightly different fractions there, but again, we're just going to use sevenths. So for this one, we should get on the first one, which you've had to go at these, is 6/7. Those two together would make a whole, 5/7, and then lastly, I went with, to use different fractions, 4/7 and 3/7. As long as your two numerators add together to make 7, you know you've got that correct. Okay, as promised, the answers appeared and ruined it there slightly. The following equilateral triangle square are put together to make the shape of a house as shown. So if you just cover up that last bit of line, I'll try and get rid of that, but that's going to stay in the video, I'm afraid there, guys. The total perimeter of the house. So if you remember, perimeter is the outside of a shape, the whole way round the outside. So I think it's easier to label up our shape so we don't make a mistake. So that's 3/5 of a metre, 3/5, and likewise all the way round. Okay, so we don't need the top of that square because we're not walking around that part. That's no longer the outside of the shape. Okay, so what we need to do for total perimeter is then add all of those together. So we've got 5 lots of 3/5 metres, written those all at the bottom. The denominators are all the same, so we simply need to add the numerators, and that's 3 plus 3 plus 3 plus 3 plus 3 is 15/5 metres, and I think that would be best to then convert to a mixed fraction, or in this case it's actually just a whole number, because 15 divided by 5 we're just going to get is 3 metres. Okay, so the perimeter of that would be 3 metres. Make sure as well you don't put anything like 3 metres squared. We use the squared for area. Okay, this was perimeter. Okay, and then this one is a bit of a recap from, I think, what was perhaps the first or second lesson you ever did at Delisle College. So hopefully you can remember this. What is the term-to-term rule for the following sequences? Okay, and then you're going to write down the next 2 terms for each sequence, and then you're going to see if you can remember, are these linear or geometric sequences. Okay, so if you pause the video there, write those sequences out, fill in the next 2, and then tell me a little bit more about term-to-term rule and what type of sequence are they. Okay, so hopefully then we have got a little bit of a reminder, in case we've forgotten as well. Sequence is a list of numbers that follow a set rule. Okay, and the rule, the term-to-term rule, describes how you get from one term to the next. So how have I got from 1/3 to 1? from 1 to 1 2/3. Okay, so hopefully from that first one, you've noticed a bit of a pattern there. Obviously, it is increasing, so we should then get 3 2/3 and then 4 1/3, because the term-to-term rule is plus 2/3 each time. It's increasing by 2/3. Okay. On the second one, we should get 1 1/5 and then 3/5. And the rule on that one, term-to-term rule, is we are taking away 3/5 each time. Now, in terms of the names of these sequences, they are both linear. It's also referred to as arithmetic sequences. What those are is there is a common difference, and that difference is either adding or subtracting exactly the same amount each time. So in the first one, we're adding 2/3 every single time, and the second one, we're subtracting 3/5 every single time. It must be common, i.e. occur on every single part of the sequence. Geometric is a common ratio. We are either multiplying or dividing by the same amount each time. Okay, and the final part we have got for today is these last 4 fractions here. You're going to calculate these for me. If you need to, draw a bar model. If you feel a little bit more confident, you can just put these answers down for me, and then you can have a bit of an experimentation on your own and have 4 of your own and make sure you answer those as well. Okay, so to round us off today, those are our 4 answers. So make sure you've marked your work throughout this, and any errors you've filled those in. Have a look on the Word document for what you've got to complete for the week, and the Hegarty clips will be up there. And, oh, I've done it again, haven't I? I've forgotten the last slide. So, back to my favourite. You've all probably switched off by now, but hopefully you've followed it through to this last bit for me. Write out these fractions, and there are some missing blocks in there. Okay, you're going to fill in those missing fractions for me. So if you write those out exactly as they are, and I would just draw the squares around the missing parts so you know which numbers you've put in yourself when it comes to marking them as well. Okay, pause the video, and then we'll pop up the answers, and then I'm slightly more convinced that is the end of the PowerPoint for today. Okay, answer-wise then, we should have 2/5, then minus 2/5. And again, on that third one that I've shown there, you may have put something slightly different. You might have gone 1/7 plus 4/7 there. Again, these last ones, you may have had something very slightly different to what I've put there. And those would be your complete answers for that. Okay, so that was what we've covered for today. So thanks again for tuning in. Look after yourselves and keep safe. And next time we'll be looking at adding and subtracting fractions with different denominators. Take care of yourselves in the meantime.